The alert came from security, not monitoring. Unusual login pattern detected for privileged accounts. Then, Slack lit up. Multiple admin logins from new IP ranges. Seeing successful logins without MFA challenge. Is MFA down? That last message stopped me. I opened the auth dashboard. Login success rate was normal. Error rate was low. Nothing looked broken. But the audit logs told a different story. Admin accounts were logging in from locations we had never seen, and none of them were triggering MFA. We were running on AWS, EKS cluster in US East 1, serving our core application, about 65 microservices. Traffic averaged around 2K requests per second. Authentication was handled by a dedicated auth service. Users logged in with username and password. Privileged accounts required MFA, time-based one-time passwords. We enforced MFA at the application layer and through our identity provider. Sessions were stored in Redis. User data lived in PostgreSQL on RDS. CI/CD was GitHub Actions with Argo CD managing deployments. Monitoring stack included Prometheus, Grafana, and Loki. Security logs were centralized through CloudWatch and fed into a detection system. From a design standpoint, MFA was mandatory for admin access. There were no exceptions. At least that was the assumption. Initial symptoms: no outages, no performance issues. Users were not complaining, but admin activity was increasing. Sensitive endpoints were being accessed. Feature flags toggled. User roles queried. All valid actions, all authenticated, but coming from sessions that bypassed MFA. We checked login flows. Normal users still required MFA. Only certain sessions skipped it. That inconsistency was the first real clue. Something was selectively disabling MFA. First thought was identity provider issue. Maybe MFA enforcement was failing upstream. We checked logs. MFA challenges were still being issued for most users, so not a global failure. Next thought was token forgery. Maybe someone had bypassed the auth flow. We inspected JWTs. Signatures were valid. Claims looked correct. No anomalies. Then we focused on the application logic, specifically where MFA was enforced. We traced a login request, password verified, MFA check triggered, except in some cases it wasn't. There was a conditional. If a certain flag was set, MFA was skipped. That flag came from configuration. Now we checked the config service. There it was, a flag. MFA required for admin, set to false. That should never happen. We checked deployment history. No recent changes. No commits touching that flag. Then we looked at runtime overrides. Feature flags were managed dynamically, and someone had changed it. About 3 hours earlier, no alert triggered, no approval required. Now Slack was escalating. Who changed MFA settings? Was this intentional? Do we have compromised accounts? We pulled audit logs for feature flag changes. The change came from an internal account used by QA. That was unexpected. A few days earlier, QA had been testing a new login flow. They needed to simulate user scenarios quickly, including admin access. To speed things up, they disabled MFA using a feature flag. It was meant for staging, but the flag system was shared across environments. No strict separation. The change was made in production by mistake, and there was no guardrail preventing it. No approval workflow, no alert, no automatic rollback. Once the flag was set to false, MFA checks were skipped for all admin accounts. From that point on, anyone with valid credentials could log in without a second factor. The system behaved exactly as configured, but the configuration was wrong. First step was immediate. We re-enabled MFA, set the flag back to true. Then we invalidated all active sessions, forced re-authentication across the board. We monitored login activity. MFA challenges resumed. Suspicious logins stopped. Next, we audited admin actions during the window, checked for unauthorized changes. Fortunately, no destructive actions were taken. Then we fixed the system. We restricted feature flag changes in production. Only specific roles could modify security-critical flags. We added approval workflows. No single person could disable MFA. We separated staging and production flag systems. No shared state. And we added alerts. Any change to authentication-related flags triggered immediate notification. What failed was not MFA itself. It was control over how MFA was enforced. We treated feature flags as operational tools, but some of them were security controls. That distinction was not enforced. Detection was delayed. We saw the effect, but not the cause. No alert when MFA was disabled, only when behavior changed. There was also an architectural issue. Shared configuration across environments created risk. A change meant for testing affected production. Engineering lessons. Security controls should not be toggleable without strict governance. Feature flags that impact authentication must be treated as critical infrastructure. Environment isolation is essential. Testing changes should never propagate to production systems. Auditability must include configuration changes, not just user actions. And finally, successful logins can be more dangerous than failures. In the end, nothing crashed, but something important was quietly turned off. Remember, successful logins can be more dangerous than failures. Protect your configurations as much as your credentials.